sbt is a de-facto standard for Scala build, and there is a reason for that. There are many reasons. One of the fundamental reasons, according to me, is the incremental compilation. Scala compiler is very slow. I think we all, those who use Scala compiler, we know it's very slow. And if you have to build all the 10,000 files or 10,000 files of a moderate size project, every time you change a file, then that will be too much of a work. So there is a part of sbt which does this incremental compilation in a very efficient way. It will analyze that which are the other files which are getting invalidated and compile only those files. And I think that's why it's an indispensable tool if you're using Scala. Okay, and because many tools like Spark, Akka, Plane, they're using Scala for implementation. sbt is also now commonly used as a build tool, and the people who submit the pull request to those open source projects, they have to understand a little bit of the build before they can do the configuration. So sbt is important. So try to give you a feel of a complete life cycle, right from searching Google to get a template to deploying and seeing how it might work in production. And this is pretty much how I do when I work with the new project. And while doing so, I will also explain what are tasks, what are settings, use some of them, right, for doing common jobs required. So what is the first and foremost, so those of you who are using Scala, what is the first thing you do when you have to get started with the Scala project? I mean, you don't have anything. You have to get started with your first story, you have to implement some ideas now. So what do you do? First thing.
Hello world for sample application is similar to what I'm like.
Right. Where do you get it from?
Templates.
Yes. Which templates? I mean, do you just search on Google templates, or is there anything specific?
Types.
Yes, types of templates. Right. That is what I do, and that is what I recommend that all of you do. That if you're doing a Play project or Akka project, you will get a lot of templates, and where to find them? You say activator templates. They are called activator templates because the code behind them, which is nothing but a wrapper on sbt, is activator. So you go here. It's a huge tool. You don't have to. The thing is that never download the tool, but just search for the good template. So and there are many. For example, Akka scala-sbt. This is the template submitted by this person. May not be up to date. It seems so. If you go and click there, so if I go here, you will see the date. Oh, it's very old, 2014. Not interested, right? So I will not go for that. For our purpose, we want to get started with the same template of a minimum Scala project. I don't want Play or to begin with. Right? So what I'm going to search is those keywords: minimal, Scala, seed, activator. Right? Those are the keywords. Seed is the main keyword, and activator and Scala. So if I do that, you will invariably land up with the top result, which is what you want. How do you know this is what you want? Well, first of all, it is from typeset. So, as a company behind Scala, they try to keep their templates up to date and use the best practices. So I think it's not bad to get started. It's also fairly recent. Now it depends on it's last year, but because Scala main version has not changed in almost 2 years now, it's still valid for the minimal Scala project. So what you do at this point is download this so there will be a link, download minimal zip file. And it should not take it should take few seconds, because the total size, if you go in the folder, total size is 1.1 MB. You see this, right? Let's unzip it. Okay, and let's go to command line. So this is the downloads folder, and this is cd minimal Scala, and this is the content of the zip. And the reason why it is more than 1 MB or 1.1 MB because of one component, and that component is inside, if you say libexec, activator launch 1.3.10. That version could be different every time, right? Now what that means and why is it so huge? We haven't even started writing a single line of code, and already we have a 1 MB zip. So now at this point, I'm expected to create a Git repository, check it in, push it to the GitHub. So the question is, this looks like a jar, it's a binary. And the recommendation is that we don't check in binaries, dependencies jar in the GitHub, but should I do that? So our recommendation is that yes, this particular one you should, because if your project life cycle is like a couple of years, this jar will hardly change ever, if at all. Because this is not the build tool, even though it's called activator, which is the name of the build tool. It is a launcher for that build tool. So it's a meta level, right? In Gradle, I am trying to recollect you talked about Gradle W, right? So Gradle W and Gradle, what is the relationship? Gradle W is a wrapper or a launcher which first gets the Gradle and required
code basically, and then launches your build, and then you can add dependencies for your project and stuff like that. So it is at that level, and this will rarely change. So you are highly encouraged to basically check this in, so that only dependency on developer machines now is Java 8 or whatever is the Java version that you are using, right? I mean, if you go vagrant and that virtual machine fashion, then even that will not be a dependency. But if you don't, then also you are good, because you just say that, okay, if your machine has Java 8, I'm going to check this code in, you check out, and just run a command which is in the bin folder, .bin.activator, right? I'm not going to do that, because as a customary thing, before I do this, I check certain things, because this template is old and I want to basically just customize it for my project. So what do I do? First of all, let's copy this. So this is a demo folder empty right now. I'm going to copy this from my downloads, minimal Scala, and I'll call it GeekNight main, right? For example, let's call it whatever, for a reason. And then I go to this folder and I see the contents, and I open the directory in Sublime. That is the first thing I do. Every time I create a new template, I will first inspect. And I start with the project folder here, right? Inside project folder, there is a build.properties. The only entry of interest is the second entry, where we specify what is the SBT version. Even though I'm using a launcher with whatever, launcher 1, 3, 10, what matters for the SBT version is the version mentioned in this file, because launcher will read this file and download the appropriate version of SBT before it launches the tool. And I know that the latest version of SBT is 0.13.11. If I'm starting a new project, I better basically make it up to date. So I will just this is the first change I will do. Let's save it. Let's go to the build. This name, I will just sanitize it. So I will say that this is main. I know that there is a Scala version which has come after 7, which is 2.11.8. That is the latest maintenance version for 2.11. So I will use that. I don't need this command. Library dependencies, there is a test library which I know. I mean, you don't have to do this, by the way, trust me. I'm doing it just to show you that what kind of customization you will do. So I will change this version. I don't need Akka or anything like that, so I will just delete this. Okay, so this is the build.sbt, which is similar to build.gradle, which lies on the top level folder, basically, of your project. And it can have a lot of details. But to begin with, we have very few. Name, version, Scala version, and library dependencies. Scala version is important because the libraries in Scala, they are not binary compatible across the major version. Like 2.10 library will not work with this project. Okay, just to show you what else was bundled. So of course the launcher was there. The script which will build my project, you don't have to open it. It's a script basically, which is activator. And some sample files which the template gave me, which I can immediately delete. But right now I don't have to. So this is the hello main method. And then there is a test file just to show you what a test will look like. And with this much setup, with this much customization, now I am ready basically to say .bin activator, right? So I'm now calling my launcher. Launcher will first go find out what version of SBT I asked for, download it if it is not there, and then start. Now this will work very fast on my machine because all the dependencies that I require is already in my cache. And the cache, which is used by Gradle, I think, I don't know the latest version of Gradle, but the Gradle earlier versions at least, and SBT is same. Ivy is the build manager which they use, and that's why the format and the storage, etc. It's shared. And if you want to see where it is located, you can say go to your home folder and say ll.iv2, right? So this is the place where all the data will be shared. And if you look at cache, then you will see so many. I mean, I must have been using a lot of Scala libraries, so they are all cached here. And when I want to launch a new project, my Scala library file, the test library file that I specified, all of that will be obtained from this location and will be put in my class path by your build, right? But I'm already in the REPL. I'm not a REPL, but in a shell basically, which is provided by the SBT. Now, even though name is activator for the launcher, for all practical purposes and for this session, it is SBT, equivalent to SBT. So I'm inside that, right? And some of the things I can start playing with at this point. For example, I can say that compile this project. This is the task which is inbuilt, which will come by default with the SBT as a build tool. So if I compile, there is only one file to compile, so it will compile and create the .class files. If you want to test, it hasn't compiled the test yet, because compilation will just compile your prod code, not the test code. When I say test, it has to first compile the test, right? So you don't have to specify that first compile. You can do that. So you can say test compile, and then you can say test, or you can just say test, and it will do both. So I'm just going to say test. So this is now compiling the test file and then running it, and some output there, right? Well, so these are the two very basic ones that you can get started. There are also others. For example, if this were a library project. Okay, by the way, does it make sense? I mean, so far, the way we started, does it make sense? All right. Is it familiar? Is it something that you have done in other build tools, like, right? I mean, so we are just describing the best practices and getting started with SBT. So the next task which I want to talk about is packaging. So if this were a library project and you wanted to basically publish it on Maven Central, as a prerequisite, you will have to first bundle it into a jar. Not only your source, but also not only your class files, but also maybe your source. You want to publish your sources. It's an open source project, and Java docs. So there are different artifacts for binaries, for sources, and for artifacts, and you can create your custom artifacts if required. For example, Scala.js will have another artifact, which will be the IR representation of the same library. We'll not go there, right? The command for that is called as package bin. So if I say package bin, then you see that it created a jar file basically, right? And now this jar file contains everything. Unfortunately, this is not a library project. This is a hello world main application. No one can use it meaningfully. But if it were a library project, I am ready to basically put this library somewhere and start using it. Okay, so that is, and then finally, if you want to, so ideally you should be pushing this to Maven Central, but there is a very strict process for pushing to Maven Central for a reason, because once the artifacts are pushed to Maven Central, they are immutable artifacts. You cannot just change them. So they have to guarantee that you are the owner of this domain, or somehow these artifacts actually belong to you. So we'll not publish to Maven Central. Rather, we'll publish to our local repository. We saw it here, right? So this is the cache, this is the IV, and inside IV there is this local repository which is on my machine. So for all development purposes, I should be able to use this. And currently it has some artifacts. Maybe we should just delete that. So I'll just go to cd.iv local rm-r. Okay. So now we don't have anything. So the task for doing that is called as publish local. So if I say publish local, then it will create the artifacts for jars, src, docs, POM file, and put it into my local cache. Currently naming is default because something is missing. We'll see what is missing. And it has the artifacts inside this folder. The version is 1. And then if you go in the jars, you will see the jar. If you go in the src, you will see the source artifacts, right? And now my own projects on my machine or with whoever I'm sharing this local repository will be able to directly depend on this and start using it. And we'll see, maybe we'll not depend on this right now, but we'll depend on something more meaningful from external world and start using that. One of the reasons why it is called default right now, if you say, is because we haven't specified a key parameter in the build, and that parameter is organization. But before we do that, why don't I start using IntelliJ? Because so far we haven't done any code change. Now this is the first time we are going to do code change, apart from customization. I'm going to just open this into my IntelliJ. So you go to IntelliJ, file, use open. Don't go to import. I mean, import, I don't even see it here, but sometimes there used to be an option import that used to mess up things. Always go to the open. And now this is not appearing because this is minimized, is it? What the hell just happened? Okay, let me close IntelliJ first. Close this project. Okay, so I'll just open, and in open I'm going to say my project is in workshops, SBT intro, demo. This is the project, right? So you just select that, and IntelliJ will figure out based on your SBT file that this is a project which can be imported. I usually click on both the sources and then import it. So let it finish. Yes. Okay. So I have the same view, but now from IntelliJ. So what I'm going to do is, I'm going to say that I want to specify organization. And organization can be specified like com.example, because that is a package structure which was given to me. I'm just going to stick with that, right? Now if I do this and now start working here, right? This will not change. For example, now if I say publish local yet again, nothing will happen. So it will still be default. Why? Because the changes I have made to the build file are not captured here, and that's a common mistake for the beginners. What you're supposed to do? Reload, right? So you say reload, which will reload the build, or you can just come out of the SBT REPL and then try to go back again, right? You reload, and now it has reloaded the build definition. And now if I say publish local, it should have done the correct thing. So now you see that this is an artifact which is in the com, and then if you go there, you will see the same usual stuff, right? Version 1 and name of the project determines the name of the artifact. The group ID is determined by the organization, and the version is determined by the version that you specified in the build, which is 1.0 right now. Clear so far? Okay, so what else I wanted to cover? Let me just go here. So I wanted to start with download, tweak, library dependencies. I will come to that in a moment. Okay, so let's use library dependencies once more. This time, let's try to build a small HTTP server so that we can do the end-to-end demo. And for that, I need Akka HTTP. What I'm going to do is, I'll search Akka HTTP and Maven. Actually, I know that the link is here in the docs folder, so I go there. And then you see all the Akka artifacts. I'm going to search for HTTP. And what I'm interested in is this one, Akka HTTP experimental with this version. So I copy this as it is, and I paste it here, but as a library dependency. So I say that library dependencies plus equals this one. And this is how I add a new library dependency for my project. Now suddenly we have two library dependencies. That is perfectly valid syntax. You can say that, okay, this is my setting. Now that is a term, that is a conceptual term in SBT. This is a key to which I can attach a setting which is of a single artifact at a time. Or I can use a slightly different variation of this, and that's what I'm going to do. So I'll say plus plus and add sequences. So this is valid, and because that is valid, I can just add multiple dependencies in one go. And this is typically how you will add library dependencies. So you will say that, okay, I'm adding multiple of them together using plus plus sign, and then specify one below the other. Of course, to be able to use it from here, I will say reload. And similar to the reload here, what I have to do is refresh project in IntelliJ. So if I do this, it should be available in my class path. Sorry? No, reloading is just reloading the definition of the build file once more, because it's kind of cached. You are not running, okay, so there is a difference between saying compile, right? This is how you would do it otherwise, right? You'll say my launcher name and a task, compile, and it will load the whole JVM and blah, blah, right? And execute and come out. What we want to do is always, I think this is roughly equivalent to the hot reload daemon mode, that roughly, I'm not sure. And then you go inside the shell so that the build definition is loaded once, and I can use the command slightly more efficiently, right? I mean, of course, this was really fast, but if I clean and then compile, then it should, I mean, it will not take time to load the project itself, but just do the task, right? So that's why the reload. And here also the same effect happens. Once I reload, those libraries are available on my class path in the project. What I'm going to do now is in my main hello, right? I'm going to say that this is, I'll call it hello1. Because I'm going to do something with hello2 maybe later on. And then instead of this main method, what I'm going to do is, I'm going to copy paste some code, because that is not our focus. And I say that, okay, get me all this code, which is using the library. So I'm just going to replace this here. And I'm just going to call this hello1. Okay. So this is the way you will write the smallest HTTP server using Akka HTTP. I'm specifying a route, which is hello, and then I'm handling a GET request. And if I get a GET request on that route, I'm completing it with a string, not even a JSON, right? Just a string basically saying that, say hello to Akka HTTP. And this is just from the web that I copied. And then this is some boilerplate that is required basically because you are using Akka HTTP as a library, not as a framework. So you have to start the server and do the stuff. I'm starting this server on the port 9000, right? So let's see how it works. So I'm going to say compile, right? And I'm going to run this. Okay, so this is listening on 9000. And now if I go to localhost 9000, I will see that server is running, but I did not specify the correct route. So if I say hello, then I see that this is what this is coming from our application, right? Which is fine. I think this was expected. But what we actually want to do, now I'll just stop this and go back in my activity. What I actually want to do is bundle this application as a whole, the way we try to bundle our meaningless hello world application, and then maybe start it from command line or deploy it as a Docker, right? So I'll just give you both of these things together. And to be able to do that, I will need a plugin, right? So I'm breaking my own sequence, but I think let's do that because that comes in a natural flow. So I'm going to go in a something called plugins. What is a plugin for Gradle? I mean Gradle or Maven. You must have used Maven plugins, right? What do they do? Any example of a Maven plugin that you have used? Any? I mean that you added to? Sorry. Oh, okay. Yeah. That is so. What is it called as once more? Oh, shading, right? Just shade, is it right? Okay. So yeah, because you want your own names instead of the default name, so that it doesn't conflict with the published versions, right? Right. Okay. So maybe that is the default way of creating a jar using a shade library. But what else? What else? What other plugins that you will use in Maven? How will you bundle your application in Maven? There will be some plugin, right? Some zip creator, some jar create, something, some bundler. Yes, everything is a plugin. But maybe you haven't used, maybe your tools internally are using that, that's fine. So what we are going to do is use a plugin which is very standard in the Scala ecosystem called SBT Native Packager. Have you heard of it? So if you go to SBT Native Packager website, this is kind of officially supported by TypeSafe. So this is the standard way of doing this, and this is pretty powerful. Now, this will also tell us how to use plugins in SBT. First thing that you have to do, I mean, let's go to the getting started, is somewhere add this line, add SBT plugin, blah, blah, the correct version and stuff like that. And the place to add that is interesting. Well, that you cannot do here. Because whatever you do here is for your project. For example, if you wanted a library to be available when you are coding your project, you will add it here, right? So this space will give you class path and other facilities that are required for your project. We are at a meta level, right? What we want is my build tool, right? Which is kind of this level where I'm writing my build script to have the ability to bundle, create the bundles of appropriate type, Docker or zip and stuff like that, right? So I have to go a meta level up. So I need a build.sbt, but that meta level is inside this project folder, right? Which is part of the template. So I create a build.sbt inside here and I add that line. But the convention is that if you're creating that build.sbt, mostly the purpose of that file will be to add plugins. So name doesn't matter, but it's called as plugin.sbt. But this is exactly like build.sbt, okay? And I add my plugin here and I specify the correct version, which is 1.1.0, which is the latest version, right? Okay, so in very, very short, SBT build is recursive, at least as of now, that is what the great idea was. Whatever is the build.sbt file outside is the build file for your code. And if your build file itself needs abilities, you have to go one level up and add a SBT file here, which is in the project/plugins.sbt. And after doing that, I will just come out because this is one meta level and then get into this back again. Okay, and right now, if I try to do, say, for example, the command is universal, but it's not available to me. So I did not do anything to make this available. So one more step is required. I do the reload here. I do the refresh project. So the plugin is added on my class path. It is available to be used, but I haven't used it. So I'm going to do that now. And that use will be in back to our level. I will say that here, enable plugins. And here the name of that plugin that I'm going to use is Java app packaging, right? So if I do this, then this plugin should be enabled. I say reload, right? And then now in the universal namespace is available, so I can autocomplete. And one of the tasks which I'm going to use in here is called as package bin. But this is not a simple package bin. This is the package bin provided by the plugin. That's why it's prefixed with universal. And I say universal package bin. It's first creating the jar and stuff like that. What it does, I think the bad part here is that it's not printing the appropriate messages, but we know what it does. So I'm going to show you that. In the target folder, you will see a universal folder. And if you go to universal, you will see that there is a zip file here, right? And it is the entire application. So if I do this, so let me go to this folder and say pwd. This is the path. Let's go to temp folder. rm-r hello. I think there was something lying around here, right? And then I'm going to unzip this. Unzip the zip file, right? Just to see how it works. So it will unzip it in the temp folder. I go in there And what I see, there are only two things. There could be more, depending on how you set up your project and how you configured this plugin. One is a bin folder and one is a lib. The lib contains, if you look at the lib, it contains all the transitive dependencies that got added because of one dependency that you added, which is HTTP. So of course, there is a HTTP somewhere here, but it also needs the HTTP core, which also needs actor. The HTTP experimental also needs a stream and so on. So all of them got together in a zip file and got added here. And in the bin file, you will have the launcher scripts, again similar to our activator script. So you can just say bin, this is just a plain script. What you see here is one for the Windows machine and one for the bash, right? So one is a bash script and one is a Windows script. And I'm ready to launch. So I'm going to say that bin main. And if I launch, it should start the server. So it's now saying that listening to the port 9000. If I go here now and say hello. So this is coming from the zip that we launched, right? So that is one way. What is really cool is you can use the same plugin and do a lot of other things. You can create RPMs, dev files. I think there is a Windows support also, and there are a lot of all crazy formats. I think their website describes all that. So the supported formats, there's a list of all of that. But the most interesting for us is Docker. So we are going to make use of that, right? To be able to do that, I think the only thing I don't even have to enable this because my top level plugin has already enabled that. The only thing I'm going to do is expose a port, because Docker will need a port, and say the syntax for that is Docker expose ports like this. So I'm going to go in my build file and say Docker exposed ports, and this is a sequence of say 9000. So this is the port I want to get exposed from my Docker container. I don't think anything else will change. So I will just go with the default. And I come in here, I reload so that my ports are recognized. And now I say that Docker : publish local. Okay, so I am using Docker on my machine, right? So this is a Docker which is now shipping in beta, which you can run on Windows machine or Mac machine without a virtual box. So that's why it's running natively and it's a bit fast. So what it did, it created an image, and we can verify that image by I'll come out of here and I'll say that Docker images, and you will see that gn main is the first repository name tagged 1.0 with our version, and it just got created with a huge size. That size is I mean, if you understand Docker, you will understand what are all the layers and stuff like that. We'll not go there. Now if you want to start this, you should be able to do that. I had a Docker run somewhere in my history, yes. So I will say that Docker run in an interactive mode so that I can stop it if I want, and map my host port to the 9000 port. So 9000 host to the 9000 of the Docker, and start this repository with this version. And it will start it. And now you can go to same. Okay, well, this will not work because now this changes to docker.local. And this is now being served from the Docker, right? And if you want to work in this mode, this is very fast. For example, what you can do is now, you can just stop this. Or you could have stopped it later, that's fine. You can go to your application and you can make a small change. You can say that ha ha ha, right? And you go here, you say that publish local, it will compile and do your job very fast. You come here, run it. It's not working. Oh, sorry, I'm running an old image, hello one. You should have pointed that out because that was my rehearsal that I was doing. So let me delete those images first. Docker images. So what I'm going to do is, I'm going to say Docker RMI, and I think let's remove all the images. and then we see that there are no images. So let's start from the scratch. So first it depends, our own build depends on the Java image basically, right? So it will first put that and then it will put the other stuff, and then let's look at the images. So there is a Java image, Java latest on which we depend, and now let's start. Now this will not work of course, right? But what will work is gn main. And it's showing you the, well, I'm not going to go and show you how quickly you can change the code, but you can expect. So even the testing for the prod setup on your local machine has a pretty quick cycle. You don't have to leave your build tool basically. You are inside your build cycle, you are refreshing. If you're using a play, you are refreshing your pages, and now you want to just verify how it will look in the prod mode, you can quickly do that. And that is because of the plugin and a lot of things which plugin is giving you out of the box. So plugins are extremely important in SBT. Most of the functionality that you will use in SBT will be via plugins. The core SBT will give you very few things, and only those things which are not available via standard plugins, and there are custom requirements for copying and zipping and merging and stuff like that, which are not standard, and that's why there are no SBT plugins. You will have to write your own tasks. And maybe we'll write one such sample task, but that is secondary, slightly secondary. Even if you read the SBT tutorial, you will come across tasks very, very early on, because task is a very fundamental idea. You should know that. But practically, you will not write tasks so early in your project, right? First, you will use some standard deployment packaging tools which are available as part of builds, and only in specific cases you will write the task, right? So plugins are most important, more important in my opinion for the beginners than the custom tasks. Okay, any questions so far? Okay, how are we doing on the time? I mean, how much do we know? When did we start? 7:15? Slightly. Okay, I'll continue. Maybe someone can interrupt. Maybe I'll stop by 8:15 or so. Okay. Okay. So this was about how do you get started and what is. So many things were available either out of the box or as plugins, and I think we covered this part early on. So I'm just going to write this here. Okay. I think just to give you an example of other plugins that are very common, right? Now, that is about Play. I mean, Play is one of the most popular web framework in Scala world. Play consists of a set of libraries that you can use, just like Akka HTTP, to start your server and do HTTP and routing and everything that you want in the web world. Or you also have tooling which will allow you to compile not only your code but also your assets like JavaScripts and SAS files and less files, CoffeeScript files, Scala.js files if you have those, right? The tooling which will allow you to do the packaging, but maybe more optimized, where the assets are packaged separately and your code is packaged separately. And many such things will be available as part of the Play tooling. So Play as a library and Play tooling, which is available as a SBT plugin together, becomes a Play framework. So when you say Play framework, you never download Play framework, right? What do? You download the template, and the template has add SBT plugin, and it says that, okay, I'm using Play plugin. And that Play plugin gives you tooling and adds appropriate libraries to your class path and stuff like that. So understanding plugin is very important as, I mean, if you're using Play, you are using plugin, and you must understand what is the implication. Gatling, for example, right? Gatling is a tool. I mean, yes, it's a library. You can use it like a library, or you can use a Gatling SBT plugin, which will give you some custom tasks for doing your performance easy. Protobufs are very commonly used across microservices as specifying the contract, and the protobuf format is language independent. It is kept in some convention in Maven in some file, and with each compilation, the protobuf also needs to be compiled so that your code can refer to the classes which are generated, the Java classes, stuff like that. That can happen automatically if you use the appropriate Scala plugin for protobuf. That is another example, right? And so on. So plugins are very important. I mean, that's the point we're trying to make here. Incremental compilation we talked about, but we did not explicitly see. We saw in the process, that's fine. External library we have seen. Console project and then tasks. Let's finish those, right? Well, one of the interesting parts, so this is not a console. This is like a shell of a REPL where the things are loaded and you can do your task, you can type your task. But what you can also do is some interactivity with your project. Now your project is not only your code but transitive dependencies, and you may want to basically try out certain things. For example, okay, this will be launched as soon as you say activator, right? That is activator or the way you created. But if you follow my story, then yes, as soon as you say activator, you will be inside this, right? And at this point you say console, and you will land up in a Scala REPL, but it's not a normal Scala REPL. It also have all the class path, all the transitive class path that your library added. And for example, now if you want to import akka.scala.dsl.source, you can import that, and then you can say source. You can create a source 1 to 10 and then do mapping and stuff like that, and you can play with the REPL, right? So if you want to try out certain things and this need not be only the library classes, this could also be your classes, but you can just take the name of that class fully qualified and call a method on it, and it will just work. And this is very handy sometimes when you want to basically work in the context of the not just you need Scala, not just the plain Scala REPL, but the REPL with full context. That is one important console. And the second, more interesting console is that if you want to debug your build script, so this is the build script that you are writing, and you're writing a custom task and you are not sure why it's behaving in certain ways. If you want to debug, there is something called as console project. Now this will start the same Scala REPL, but not with your dependencies of your own project's libraries, but the dependencies which are required to write the build file so that you can debug this. Let's see. So you go in console project, and it added all the libraries which are required basically to work meaningfully. And now I want to say what is the organization, right? So this is a organization, and it will say, oh well, it is a setting, it is a key, it is a setting key which holds a string value. If I want to get the value, I will say eval. And it will tell me that, okay, this is a simple string, right? It's not very interesting, but you can also eval a task. For example, compile is a task, and you'll have to specify the full code, compile, in compile, because compilation of the prod code is called as compile in compile, and compilation of the test code is called as compile in test. Those are the confusing things. So if I say this, it will actually show you that if I eval this, then what will be the result. I'm not sure if I change a file. For example, if I change this route to hello1 and run this, yes. So now it will actually detect that, incremental compiler will detect that one file has changed. It will evaluate that, and then evaluation itself is a value which is of a type analysis that you can use to log appropriately and report and stuff like that, which you get the picture, right? You can evaluate tasks, you can evaluate settings, of course, and this is for example, I want to find out what is my class path. So those are called dependencies. So dependency class path, right? In compile. So that is that. And if I want to actually evaluate it, I will say .eval. And you see a list of this. Now this is a usual Scala REPL, so you can actually iterate over this. You can say for each print line, and you will see that, okay, these are all the libraries that are being added to the class path. Okay, so I think this is those are the things. Now the remaining things, I am wondering whether we have time because it's already 8:15. So should we continue 15 more minutes, or should we take a? Sorry, how many people want to continue? A minority actually. So should we? Okay, let's continue. Let's continue because people are hungry also maybe. So let's continue for a while. Let's just write a task and then we'll stop. We'll not do the multi-project and writing a custom plugin. I think that will be just too much. How do you write a task? So I want to write a task which will depend on, so there is a task are always depend on other tasks, right? So I want to write a task which will depend on the packaging task, which will create a jar file. And then for whatever reason, it will just copy this into a particular location in target, maybe top level target, right? That is what we want to do. So how do you do that? Well, there is some boilerplate here, some ritual. So you say that, well, what should be the name of that task? I will say that copy artifact, right? That is the name of the task. And you say is equal to, you have to first define a key. So you say task key. What should it return after it has done its job? It required a file from the packaging task. So maybe it makes sense that after copying, it should just return that same file. So I will say that it will be a key that will hold a file value. And this is a small description that copies package jar in target, right? Something like that. So that is the first step. You define a key. And now you associate this key with a body that will actually do the work and that will specify the dependencies. So I say copy artifact. This is how you associate. And you say that, you know what, you have to depend on package bin in compile, the value of this, and that value is a file, right? So I'll say that this is my src file, whatever src file is this, and my destination file, dest file, is equal to, I want to start with the base directory. Now base directory could be different. It may not be the top level. If you have multiple projects, it will be the base directory of that project, right? So you have to be in context. So I use another setting saying base directory dot value, whatever is the value in this context, slash target slash copied dot jar, for example, right? And then I use a helper called io.copy file source file to destination file. And there is a flag which I don't care right now. So I'll just say true. And then after I have copied, I will just return the destination file so that my types match. And then it will compile, right? So this is how you will write a task. You first define a key. With the key, you will specify the type, which type this key will hold. It's a file right now. And then you will associate that a key with a value, which is a body basically. And then in that body, you will specify where is the source, where is the destination, where is the actual action, and return that. Now, to be able to do that, I need to first come out of here. I need to reload. I reload. So my definition got reloaded. Now I go and see in target. So I see target. There is no jar here, but I'm going to now say copy artifact. And if I do this, you should see that copied jar here, right? So this is how you will write a task. And the natural extension of writing a task is making it available to your peers or to the world. And that is where you will land up with the plugins. So I think we should stop at this point. Maybe some questions.